Good morning, friends. After long back, I again comes to the next topic, that is T and pi network, which is very useful to make the equivalent circuit of the network, as well as it is often used to deliver electrical power from the source to the load. The diagram of the network is like T in the English alphabet shape. The three impedances Z1, Z2, and Z3 are arranged in the form of a T network. This is a T network, and this T network is this part, and this part. These three impedances show the T shape of the network in the mesh. Thus, other than these impedances, the source is ES and source impedance is ZS in one side, and on the other side there is a load ZL, as we like to take the output from the ZL EO. This is output. This is output. Here, these are the T, Z1, Z2, and Z3. This is the T shape, and that's why it is named as a T network. Now, the interesting thing is there are two loops, loop 1 and loop 2. We have discussed this network in +2 level. That is, there are two mesh, star and delta, something like that. But in this state, that is in undergraduate level, there is a mesh equation which can be expressed like the matrix formulation point of view. So Z11 into I1 plus Z12 into I2 is equal to E1. This is equation 1. And Z21 I1 plus Z22 I2 is equal to E2. And this is equation number 2. Where Z11 and Z22 are self impedances, and Z12, Z21 are known as mutual. Mutual impedances means the impedance which is common to the two mesh 1 and mesh 2. And self impedance means the complete impedance value, where the numerical value are the symbolic value. Z11 is ZS, Z1 and Z3. Z22 is Z3, Z2 and ZL. And Z12, Z21, this is minus Z3. And E1 is ES, that is source applied, and E2 is equal to 0 because no source in, this is no source in loop 2. Loop 2, there is no source, and that's why this value E2 is equal to 0. Then there is a famous Cramer's rule. This Cramer's rule, through which we can write the expression for the current I1 and I2. And this Cramer's rule can be expressed in the form of the matrix equation. This I1 is equal to this matrix equation E1, E2 and Z1, Z2. This divided by Z11, Z12, Z21, Z22. So basically this can be expressed I matrix, here it is Z matrix is equal to source matrix, this part. This is the basic concept of this. So I1 can be expressed as C11 upon Z into E1 plus C21 upon Z E2. So what we are doing basically, this is the impedance determinant Z11, Z12, Z21, Z22. So if we want to find out the current I1, then we replace the first column impedance by source values, that is E1 and E2. Similarly, if we want to find out E2, I2 current in second loop, then we have to replace second column of this matrix as it is given in case of I2. I2 is equal to Z11, E1, Z21, E2 divided by Z11, Z12, Z21, Z22. So we replace this second column. This is column first of the impedance matrix, and this is column second of the impedance matrix. So what is the value of Z? The value of Z can be assessed through this relation, that is Z11 into Z22 minus Z12 into Z21. And we find this one is the expression, and this expression solve, and this solve compact form is this much. So we find this E2 is equal to 0 by putting this. We have to final E1, this I1 expression, and I1 is this value. Similarly, I2 is equal to, these are the determinants, and on the solving this determinants again, this E2 is equal to 0. So this value is 0. So minus Z21 into E1 upon Z11 into Z22 minus Z12 Z21. So E2, this I2 current expression, this is current expression in mesh 2, current expression in mesh 2, this I2. So E2 is 0. So E1 is here. So E1 C12 upon this is Z. So what is the advantage? The advantage is we have to write the current equation I1 and I2 using Cramer's rule, and then after the evaluation of the current in the meshes, we can have the voltage across the impedance load ZL, output voltage. So which is the output voltage of the circuit, and is therefore given E output is equal to I2 into ZL. So I2 is the value that is determined in this case. So E1 JC12 upon mod Z into ZL. ZL is the load impedance, and substituting this value of the various Z11, Z22 minus Z12 into Z22. So we'll get this one. So the output across the second loop in the circuit will be the value of this expression. So finally, the importance is the cofactor. Importance is the cofactor. Cofactor in the determinant, something like C11, C21, and here it is the cofactors. Cofactors is C12 and C22. So these cofactors, as we have find out in earlier cases. Then similarly, the pi network. Pi network is again with the same concept of the pi. That is the pi-shaped network consists of three impedances, ZA, ZB, and ZC. So this one is the pi, and the pi impedance is attached in this form in the network. So it is known as pi network. So in this case, this one is ZA, ZB, and ZC constitute the pi-like shape, and Z1 is connected to the source. This one is a source ES, and this source is ES, and the source impedance is ZS. And here Z3, ZC is in parallel with the ZL, and this is the load. ZL is the load, and through the ZL we can find out E output, that is output of the load. So in this case, in the pi network, there are three loops, three meshes, loop 1, loop 2, and loop 3. So in case of three loops, there must be three currents, that is I1, I2 and I3. So with the help of these three currents, we have to write the mesh equation. The mesh equation is Z11 I1 plus Z12 I2 plus Z13 I3 is equal to E1. Z21 I1 plus Z22 I2 plus Z23 I3 is equal to E2. And Z this is 31 I1, Z32 I2, Z33 I3 is equal to E3, where Z11, Z22, Z33 are self impedances, while Z12 is equal to Z21 is minus ZA. This minus ZA is the impedance which is common in between loop 1 and loop 2. Similarly, Z23 is equal to Z32, that is minus ZC, that is this loop Z3. This loop is common in between loop 2 and loop 3. And there is no common impedance in loop 1 and loop 3. So therefore, Z13 and Z31 is equal to 0. That is no mutual impedance between the loop 1 and 2. The sources are E1 is equal to this source ES, while E2 and E3 is equal to 0, because in this loop 2 and loop 3, there are no source as. So using these three equations, we can determine a matrix, and the matrix is as it was in I matrix. This is the current matrix. Here it is Z impedance matrix, and this is E. This is the source matrix. So on the basis of this equation, we can formulate a matrix, and by using the Cramer's rule, the expression for current can be written directly. We can write the current by using the same concept through the T network. So if you want to find I1 loop 1 current, so we have to replace first column of the impedance matrix by the source matrix. So impedance matrix is Z11, Z12, Z13, Z21, Z22, Z23, Z31, Z32, Z33. So this one is the impedance matrix, and we replace the first column for the I1. So E1, E2, E3 are the elements of this determinant by replacing Z11, Z21, and Z31 first column. And now we have to find out cofactor. Here the cofactor is important. If we want to find the C11 cofactor, so we have to eliminate first column and first row. So remaining the element is are Z22, Z23, Z32, and Z33. These are the cofactor, that is C11. Similarly, C21 means this one is. So eliminating the second row and first column, So the elements are Z12, Z13, Z32, Z33. Similarly, ZC1, 3 cofactors. So eliminating the first column and the third row, we find the elements are Z12, Z13, Z22, Z23. So in the intermediate, we have read the determinants and its cofactor. So these are the cofactors, and these cofactors are C1, this is C11, and this one is C21, and this is C13. E1, E2, E3 are the sources. In the given pi network, E2 and E3 are 0 because there is no source in loop 2 and 3. So there is only one source, that is E1. So E1 is finite, and remaining two terms are 0. So we can solve the other part also in the same way for the currents, that is I2 and I3. So for I2, for the current I2, what we have to, we replace second column. This is the column 2 of this whole matrix. determinant, impedance determinants by the source. And then we find this one is the value where the cofactors, again, the cofactors of this second column is C12, C22, and here it is C32. And again, the similar condition, E2 is equal to 0, E3 is equal to 0 because there is no source on the second and third mesh, and therefore the values E2 and E3 are 0. Again, this one is E1. So this one is the expression for current I2. And I3, for I3, we have to replace this third column with of this impedance matrix by the source values. So we have again I3. Again in I3, E2 and E3 is 0. So we have only E1. E1 is the value. So this one is the I3. This one is the I3, expression of I3. So on the basis of the expression of I3, we can find out the output value of the given pi network. And the output voltage is nothing but it is the load potential drop across the load ZL. So the E output is equal to E0, and this is the current I3 multiply with the ZL, that is impedance. So these are the current value I3, and here it is the load value ZL. So finding these are the expression for E0. So this is the potential drop across the load ZL in pi network. Now the important thing is, in order to solve the complicated circuit, we have to find out the equivalent of the T network to pi network and pi network to T network. Because on the conversion of this equivalent, we have also studied +2 level that there is a need of the conversion because of finding the equivalent resistance of the given circuit. So equivalency in T and pi network, as the T and pi network can be made electrically equivalent by a proper choice of their impedances. Both are three-terminal network with terminal 3 is common in between the input section and output section. These can be drawn as, here it is, you see this is terminal 1, terminal 2, and 3 is the common. So 1 and 3 we have the input section, and 2 and 3 we have like a output section in the T network. Similarly, in case of pi network, 1 and 3 is the input section, and 2 and 3 is the output section. So we have to convert this from this input equivalent to output in case of T network as well as pi network. So let us consider the first T network. The impedance between any two terminals are same in both the networks, and these networks are you can say Z12, this is Z impedance 1, and 2, this is Z12 or Z13. So Z13 in the T network is equal to this Z1 plus Z3. This is Z1 plus Z3. Because this point is open, therefore we cannot consider this Z3, Z2. So Z2 is not considered in this case. What about, this is the T network part. Now in case of pi network, we find this is 1 and 3. So this is 1 and 3. So you see ZB and ZC. These two impedances are in series, and these resultant of these two series impedances is parallel to ZA. This can be drawn as Z13 in pi is ZA. This is 1 and this is 3. So this is ZA, and this one is series combination of ZB, ZC. So what is the equivalent circuit? 1 by ZC, 1 by Z dash is equal to 1 by ZA. This is parallel with the series combination of ZB and ZC. So ZB plus ZC. So this one is a resultant, that is ZA, and here it is ZB, ZC. So finally we got the value Z13. Z13 is ZA and into ZB plus ZC. divided by ZA, ZB, and ZC. So these are the equivalent of the 1 and 3. So this value, that is 1 and 3 value, is this is Z13 of T is equal to Z13 of pi. So Z1 plus Z3 is equal to this value in pi network. Similarly, from the terminal 1 and 3 and terminal 1 and 2, so in case of T network, here it is T network, and this is the value 1, 2, 3, 4. 3. This is 3. So Z1, Z2, and Z3. So 1 and 2 network, the value is Z1 plus Z2. This Z1 plus Z2 because 3 is open. This is the T network. What about the pi network? We see this is the 1 and 2. This is 1 and 2. So this ZB is parallel to series combination of ZA and ZC. Means ZA and ZC, these two impedance are in series first, and then that will be parallel to ZB. So we can see as this is a ZB, this is ZB, and this is ZA plus ZC. ZA plus ZC is the given as. So the equivalent is 1 upon Z double dash of this equivalent 1 upon ZB and parallel to this ZA ZC. So it is ZA ZB and ZC ZA B dot ZA ZC. So what we find, this is the T of Z1 Z2 of T, and this is ZB into ZA plus ZC upon ZA plus ZB plus ZC. This is the pi network. This is the pi network, and this is the T network. Similarly, the similar impedances across terminal 2, 3, across terminal 2, 3. So these are the series combinations Z2, Z3. Z1 is free. So Z2, 3 of T is Z2 plus Z3. This is the T network of this. This T is, and in case of the pi network, this ZC is parallel with the ZA and ZB, which are in series combination. So this one is the series combination. So these are two parallel lines of the impedances. So 1 upon Z triple dash is equal to 1 upon ZC, which is parallel to ZA plus ZB. So this Z2, Z3 is the terminal in between 2 and 3, which is equivalent to ZC into ZA plus ZB divided by ZA, ZB, ZC of the pi network. So what we have done till time, we have just find out the various case of the terminal equivalent resistances. And now if the component wise expression are the same, then we can sum all these impedances. So Z1 plus Z3 in between 1 and 3, Z1, Z2 in between 1 and 2, Z2, Z3 in between 2 and 3. So these are the impedances in T network, and these are expression ZA into ZB plus ZC plus ZB into ZA plus ZC plus ZC into ZA plus ZB. The whole expression is divided by ZA plus ZB plus ZC. So what happened? Here it is Z1 is here and Z1 is here. So we have two Z1, Z3 is here, Z3 is here, Z2 is here, and here it is Z2 is here. So all these impedances are twice in number, and therefore 2 is common, and in the bracket Z1 plus Z2 plus Z3 of T network. Similarly, we multiply the two pairs and we find that ZA, ZB here and ZB, ZA is here. So it is also in twice of the pairs ZA, ZB, ZB, ZC, ZC, ZA divided by ZA plus ZB plus ZC. So this is the two has been cancelled. So Z1 plus Z2 plus Z3 of T is equal to this of the pi. So these are the total impedances sum and in T network, and this the total impedances in the pi network. So what we have to do? We have to subtracting equation 1 from equation 4. In equation 4, we have Z1 plus Z2 plus Z3. In equation 1, we have Z1 and Z3. So the value is Z2. This value is Z2. By subtracting, these two terms are cancelled. The one remaining is Z2. So this is the expression of Z2. Similarly, from equation 5, subtracting equation 2, we find the Z3. So this is the expression of Z3. And similarly, we can have the expression for Z1. That is equation 3 subtracting my equation from 4. So we have, this is equation 3 minus equation 4. That is, there is a subtraction of Z2, Z3 from the given expression. So it is cancel Z2 and with minus Z2, Z3 and minus Z of T. So Z1 is equal to this part. So we find individual Z1 expression, Z2 expression, Z3 expression in terms of ZA, ZB, ZC. What it means? If the pi network is given, what means if the pi network is given, then we can design a T network with the help of pi network. And we can also have the pi network in terms of the impedances on T network. This one is given. If we multiply Z1, Z2, Z2, Z3, Z3, Z1 of T, then we find this kind of the expression. That is ZA, ZB, ZC. So ZB is the square term. Here ZA is the square term. Here ZC is the square term. So what is the importance? The importance of this one is, if you take the common of 3 multiplication, ZA into ZB into ZC. These 3 multiplication, if you take common, then we find this one is ZB plus ZA plus ZC. And here denominator, this square factor is. So it is the cancel. And then finally we have ZA, ZB, ZC multiplication and upon divided by ZA plus ZB plus ZC. So what is this? This is the combination of all 3 resistances in pi network. This is the combination of all 3 resistances in T network. So in this case, T network is given. And on the basis of T network, we have to design the pi network. So pi network means we have to find the value of ZA, we have to find value of ZB, we have to find the value of ZC. So ZC, you see this one is divided. Consider this part. So if we divide, then we'll get this one is ZC. So what is ZC? ZC is equal to Z1, Z2 plus Z2, Z3 plus Z3, Z1. And this one is divided by Z1. So this combination is same everywhere. Means for ZA, for ZB, for ZC. So you see, in case of ZC, there is a divided of this expression by Z1. Similarly, we have very interesting results in other 2 cases. That is, the 2 cases are something similar as it is. You see, for the sake of remembering the expressions in the equivalent network can be expressed by assuming the given values are inside of the circle and the unknown impedances are outside of the circle. Means inside Z1, Z2, Z3, these values are given. Means T network is given. And you have to construct pi network from T to pi network. So we have to find the value of ZA, ZB, ZC for from T to pi. For T to pi, the T is given, and we have to find out pi network. Means we need the ZA, ZB, and ZC. So this ZA, as in previous discussions, we find the expression are common, and we have to divide by Z2. In case of ZB, this is divided by Z3. In case of ZC, this is divided by Z1. And the expression, the pair expression is Z1, Z2 plus Z2, Z3, and Z2. So how to remember? You see, this cyclic order, if you find the ZA, and here in front of ZA there is a Z2. So Z2 is divided. This Z2 is divided with multiplication of pair Z1, Z2, Z2, Z3, and Z3, Z1. Similarly, we find the ZB. ZB find the in front of ZB, Z3. Here it is divided by Z3 for ZB, and the remaining part is same. We have to find ZC. So in front of ZC there is a Z1. So Z1 is here for ZC, and this factor is same as in the above case. So if the T network is given, we can draw the pi network. Now the second part is from pi network, means pi networks are given, ZA, ZB, ZC. These three are given. So we have to find T network, means pi is given, and from pi to T, pi to T. So what do we find? This one is Z1. Z1, what is Z1? ZA, ZB upon ZA plus ZB plus ZC. So these factors are common in all cases. So how to remember it? If you find Z1, so you have to multiply again ZA, ZB in between. Here it is Z2, there multiply B and C, ZB and ZC. Here it is Z3, you have to multiply C into A, ZA, ZC. So ZA plus ZB plus ZC. These three combination are common, and we have to just multiply in this case is as it is. So what is this? This one is a way to remembering. This one is a way to remembering the impedances. One thing, and the second important thing, that is dimensionally. You see, if the two resistors here, what impedance is square? So this is divided by impedance. Here also the impedance is square divided by impedance. So always keep in mind that the multiplication terms are in the numerator and denominator has the single power. So that this 2 is cancelled here, and this is also cancelled with the help of this one. So there are two tricks. These two tricks are used to remember how to transfer T network into pi network and pi network to T network. Now we have to take the examples, and on the basis of this example, we have to try to clarify the values of network in the given sequence. Now here it is the example one. The pi network and T network in equivalent connections are given. This one is given 1, 2, 3. These are the three terminals. If all the elements of pi network are scaled, this scaled is increasing by the factor alpha, alpha is greater than 1, then find the elements of the corresponding T network. Means the pi network factor means ZA, this is ZB and ZC. The pi network has impedances as ZA, ZB and ZC. It corresponds to the T network that is represented by Z1, Z2 and ZC. So the expression for Z1 means pi is given and we have to find out the Z1. This is Z1, Z2 and Z3. So Z1 is ZA, ZB multiply and divided by ZA plus ZB plus ZC. Here, similarly, this is Z2 and Z3 as from the previous cyclic order we have to find out. Now given factor is all elements of pi network. All elements of pi are scaled by a factor alpha. That is alpha ZA, alpha ZB, and alpha ZC. So what does mean by the given statement? ZA is scaled alpha ZB, ZA, and ZB is scaled to the alpha ZB, and ZC is scaled to the alpha ZC. This is scaled means in place of ZA, ZB, ZC, we have to write alpha ZA, alpha ZB, and alpha ZC. So let us see what happened. Suppose T network elements are Z1 dash. It is not Z, but it is Z1 dash other than Z. So what we will find? Alpha ZA into alpha ZB upon alpha ZA plus alpha ZB plus alpha ZC. Similarly, Z2 dash. Z2 dash, again, we have to find substituting the value by the changed impedances in the pi network. So what will happen? You see, alpha ZA into alpha ZB. So alpha into alpha, alpha square, and here it is alpha, alpha, and alpha. So alpha is taken count. So ZA, ZB upon ZA plus ZB plus ZA. This originally value of ZA, Z1. So Z1 dash is nothing but alpha multiply Z1. Similarly, Z2 dash is nothing but alpha multiply Z2 by solving these two expressions in the two steps. Z3 dash, here it is Z3 dash is the same. Alpha multiply Z3 is the answer. This is the answer. So this one is the important expression, and the second expression is again very important for especially those students who are belonging from electronics stream, because this one is a new concept that we have given the value in 0 and 1, that is the something like digital mode. So the question is, suppose the input voltages V1, V2 and V3 in the circuit can assume values of either 0 or 1. 0 means ground, and 1 means the maximum value of the voltage. So there are thus 8 possible combinations of input voltages. Compute output for each of these possibilities. Means we have to find out 8 outputs because the 8 possibilities are given. So this one is the network given. You see in what network? This is the ground, 0, and here it is ground, it is 0. So this impedance is 2R, 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 and here it is R, R1, R1, and here it is 2R. So this kind of network is given. This kind of network is given, and in this network we have to find out the V output. So this one is a special kind of the numerical problem we have to find out. And again, I'm repeating, this one is important for the students who are from electronics group, because 0 and 1 digital electronics, they have to vastly study about the digital part. So what will happen? You see, if we are connecting with the sources, 1, 2, 3, 3 sources, V1, V2, V3 sources are connected to the network, then we have 3 mesh equation, I1, I2, and I3. These are 3 mesh equations, and here it is I4, this mesh equation. This mesh equation is also be considered as from the ground to R, and then we have to take output. So what happened? There are 4 equations, that is equation 1, add Z11 I1 plus Z12 I2 plus Z13 I3 plus Z14 I4 is E. So what is the beauty of this kind of expression in matrix manipulation? Because we have to write down the expression directly without evaluating which vector is finite, which element is not given. So we have to find out this one is, again, from this equation, these 4 equation, we can have Z and I with this part. Now we have to find out the output voltage, V output. So for V output, we find I4, the 4th current, that is I4 into 2R. So what is the I4? I4 is directly given using the Cramer's rule. That's the C14Z mod Z E1 plus C24 mod Z E2 plus C34 mod Z E3 plus Z44 upon mod Z into E4. We know that there is no source on the 4th mesh, therefore E4 is 0. So what kind of the change in the equation is there? The change of equation is expressed in this way. By solving this value, we have very interesting. This output V0 is, we are related with V1 by 3, V2 by 6, V3 by 12. And what about V4? V4 is equal to 0 because no source in fourth mesh. No source is there in the fourth mesh. So this V4 is, there is no terms. So after solving the cofactor of the matrix, we find this kind of output. The V output for the various values of V1, V2, V3 for 8 possibilities are given. So basically what is this? This is the three input table. Three input table, that is sometime A, B, C, and here it is VO output. So if three input table, so 2 raised to the power 3, that is 8. 8 possibilities are given. So these are the 8. 1, 2, 3, 4, 5, 6, 7, and this is 8. 8 possibilities are the 0. So in 3 output, the first one is 0, 0, 0. All are 0. So similarly, V1, 0, V2, 0, and V3, 0. So V1, 0, V2, 0, V3, 0. If all these values are 0, so what will be the output? Output will be 0. So other possibility 0, 0, 1. So V3 is 1. This V3 is 1, V1, V2 is 0, 0. So this is 1 by 12. V3 by 12, 1 upon 12. This is the V3 because V3 is 1. Either it is 1 or 0. So the third possibility is 0, 1, 0. So V2 is 1 and rest part is 0. So this is 1, 1 by 6. This is 1 by 6. See 1, 0, 0. The fourth possibility, that is 1. V1 is 1 and V2, V3 is 0. So 1 by 3. So this is 1 by 3. Now the combination of two inputs are finite, 1, 1. Fifth is 1, 1. So V1 is 0. So 1 by 6 and 1 by 12. And this is 1 by 4. This is 1. This 6 is 1, 0, 1. So V1 is 1. This is 1 by 3 plus 0 plus 1 by 12. So 1 by 3 plus 1 by 12 is 5 by 12. So seventh possibility is this is 1, 1, 0. So V3 is 0. So 1 by 3 plus 1 by 6. 1 by 3 plus 1 by 6 is 2 by 3 by 6. So it is 1 by 2. And the last possibility is all the inputs are 1, 1, 1. So 1 by 3 plus 1 by 6 plus 1 by 12. So it is 7 by 12. 7 by 12. So these are the 8 outputs. This question is again important for digital electronics as well. So this network is a unique network, and this one is. So basically, where we use this kind of the network in the electronic circuit. So in case of electronic circuit, we are doing this kind of the job, and this is all about your T-pi network and equivalent part. In the next video, we like to discuss about the network theorem, that is Thenning's, Norton, maximum power, reciprocity, and its application. So this is all about the today lecture. Thank you.